Welcome to EDU World Space.
29.28, we imagine that we have a 120 volt RMS AC voltage, comes out of the wall sockets in North America, and we want to rectify that and then apply the output of the rectifier to a 31 kilo ohm load resistance. And so then we want to find what the average current through that resistance is going to be without any sort of capacitance to filter things, if we have a half wave rectifier and then if we have a full wave rectifier. So if we have a half wave rectifier, then the current is going to be zero half of the time. That's sort of their distinguishing characteristic. And so we're going to approximate the average current as being the appropriate fraction of the full RMS current, which, since it's positive because of the rectifier, should work out pretty well for us. So the average current then is going to be, or our estimate at least, is going to be 1/2 times our RMS input voltage divided by R. And again, if we had full wave, if we had just applied our 120 volts directly to the resistor, this would be the RMS current. The average current would be 0 because it's an alternating current we're applying. But now, because the current is always positive, the average and the RMS are going to actually correspond with one another, more or less. So in any event, just putting our numbers in here, we get that this will be 1.9 milliamps. And now similarly, we're going to just imagine that the average current when we have, and this is again not a terribly wrong assumption, that the average current is going to be the RMS current, since the current is all now positive. So VRMS over R, and so this is just going to be twice that. It's going to round to be 3.9 milliamps. And in reality, you'd want to take account of the diode voltage drops and things. But for, just roughly estimating it, this works, perfectly well. And so there we go.